Hi, welcome to Capacity TV. My name is Burkitt-Gray and I'm editor-at-large at Capacity Magazine. We are live here at ITW 2022 just outside Washington DC, and I'm delighted to be joined by Bob Brumley, who's CEO at Laserlight Communications. Is that right, Bob?
That's exactly right, Alan, and it's a pleasure to be here.
So you have just announced, and it's in the ITW Daily that we've been publishing, the really exciting project to build a new fiber and satellite all laser network, which is hence your name. Tell us about it in a couple of sentences.
Well, first, this is a great show. We've had not only a tremendous number of panels and one we had a chance to participate in, but it's so good for telecom to be back. And not only back in a sense of building what used to be built, but new technologies, new ventures, and we happen to be just one of those. What we have been doing for the past number of years is going through the design portion of what we call the network of the future. For simplicity, the network of the past is copper, the network of today is fiber, the network of the future is going to be converged optical. Converged what? Converged ground networks, converged subsea cables, and converged satellite.
Right. And these satellites, unlike most satellites, will use lasers to communicate.
They will. Everyone likes to use lasers because that's the sizzle in the story. They're really optical satellite links. They're cross links, which people talk about, inter-satellite links. They're very hot right now, thanks to the U.S. Air Force Space Development Agency. They're buying them in fairly decent numbers, which is driving the unit cost down, which will create more applications. But they're also the up and down links, which are called laser communication terminals. Think of them as we call them telescopes. Those handle the links from the Earth to the satellite and the satellite back down to the Earth. Those LCTs and those inter-satellite links for us form an all-optical satellite constellation delivering optical satellite as a service. And you converge that into the existing terrestrial optical systems, and you have now a global distribution network, which is all optical, and consequently, from a standardization standpoint, all compliant, all equivalent, and then you do major business transformation at the edge.
Right. Now, when 2 years ago I first talked to you on Zoom from London, in London it was pouring with rain. It doesn't always do that, but you know, London has a bad reputation, but it's unjustified, but it was pouring with rain. So what do you do when there's total cloud cover?
Well, we bypass the weather, and we don't try to burn through it. We have several patents in the United States that essentially take in atmospheric data, because you see the rain, but really the weather goes up through the troposphere. So there's a lot of really bad stuff that's going up there. The beautiful thing about the weather, like today, is that we had a storm 2 days ago here and the weather cleared. So the weather clears behind what would be turbulent atmospheric conditions, and it creates what we call CFLOS, clear line of sight. And so the clear line of sight allows us to operate the system. So when we talked before, I sent you to I believe a Met Office website that showed you the radar conditions of weather over the UK. So our principle is that generally if it's raining in Newport, it's clear in Dover. And then when it's raining in Dover, it cleared in Newport.
So it's just a few milliseconds apart in terms of latency.
And for distribution, you're right, because the difference between Dover and Newport on fiber is that our system will automatically, and that's the elastic nature of it, it'll pick the route. It has to default to an algorithm of best route and best latency. So it analyzes the atmospheric data relative to where the delivery point's going to be, and it'll say this one's open, this one's going to not be open, this one's closed. It'll take the one that's open, and that's why we need a ground network. And the ground network basically backhauls from what would be the open node at the moment to the ultimate location, whether it be a premises or a data center or a government building.
You're going to have real systems on the ground, not yet in the satellites, but on the ground, and you're working with Nokia, and this is what you've just announced here at ITW. Yes. Tell us about that.
The network, we're really building two networks and then converging them. Network number one is going to be the ground network. And we selected, and we're really happy that we did this. So we selected Nokia not only as our prime vendor for our beta trial, which is going to trial all these principles that we're laying out, but also is going to be the strategic integrator. We also have picked our ground construction prime that is going to handle outside plant and construction. The plan is 16 POPs, which was really 16 edge micro data centers, 5 in Africa, 3 in Australia, 4 in the US, and 4 in Europe, all connected on fiber, and that we have this footprint. Crawl, walk, run. This is the crawl period. We hope to light that in third quarter of this year. We have a phrase, 5 and 6. 5 POPs in Africa in 6 weeks. And that's to have the design done. We light in the next quarter, Q3, and then we put traffic on it and revenue generate off of it in Q3. So this has been a huge sprint, not crawl, but it's been a sprint for the last 3 quarters. Once we take the lessons learned on performance of the ground network. Now we're building a brand new ground network. This is an SDN, end-to-end ground network. It is also emphasizing high speed, high throughput, bypassing TCP/IP wherever it makes congestion or doesn't make any sense. Remember, the overall converged network has a simple protocol: best route, best latency. Bypassing TCP/IP is a way to achieve that. Software, however, has to think about it and has to figure out the best route when the customer is ordering the service. So you're talking about millisecond analytics. A human can't pick that. So what we use, ironically, first thing we use to run the network is the weather. Where is the weather? That dictates part of the route. Then where the customer wants to go, and then where is our backhaul network to be located, and then you put it all together and you have a converged network that is high speed, high throughput, and most efficient, which at the end sets it up for other applications that benefit from that, like virtual reality.
You've mentioned customers a few times, Bob. What sort of customers are you aiming at? Because you must have customers in mind for your business plan.
We think that when the fully converged network rolls out, we have customers who will be interested in what we call a global data plan. Like your global wireless plan, we essentially offer them a global data plan. There's 53 zettabytes of estimated traffic that's going to be going around the earth by 2025. There are 40 companies in the world that account for 60% of that. Those are the customers, whether it be Google or Meta, or it would be content delivery companies like Fastly or Akamai or Cloudflare, or it would be service providers, CSPs, or it would be enterprises that are doing global MRI and imagery like GE, global compute like IBM or AWS or Oracle. That's our universe. We don't do the internet. That is not our program. I'll leave it to Elon Musk to reinvent the internet. That's not what we want to do. What we want to reinvent is, or really enhance, is data as a commodity. Not data as a service, but as a commodity. If we could create in the 4th Industrial Revolution a utility functionality here on data, not just delivery, but data management, and push it closer and closer and closer to the subscriber, you get to this really interesting dynamic that we're in now thanks to COVID: disaggregation of offices, disaggregation of tasks, modularity of service delivery and hardware. And what you get more out of all that is you get faster, cheaper, more relevant, closer data usage by the consumer and the enterprise. The satellites are planned to go up in Q4 2024. They run parallel with what would be the global build, which is going to be 150 ground node systems deployed worldwide, serving significant number of markets. These are not niche markets. We're going after where the money is, which is in the economic centers and the suburban malls and shopping centers and high growth suburbs, et cetera. The satellites provide an overlayer. So when they come in, they're checking into not having the burden of having to create what would be new interconnection points or anything like that. They're checking into a purpose-built network. And when they check into it, the first 4 come up, they're 12, and they're in MEO at 10,000 kilometers. It's below the GPS, it's above O3B, it's above some of the other MEOs. It's a nice neighborhood. It doesn't have the crowding and some of the multiple.
Debris as well, I guess.
No, not in MEO. Meo's a nice neighborhood. Now, it's not a very good neighborhood for, you have to harden your satellites because of the Van Allen belt. But the point being is once you get them up, then they seamlessly check into your network, and then you converge it. The key engineering and business case are balanced on 4 principles. Convergence, meaning we put all these mediums, space, ground, subsea, together into a single fabric, number 1. Equivalency. RF satellites are narrowband. Optical satellites are not. They are equivalent to broadband fixed line. So you're operating at 100 gig, 200 gig, 400 gig service speeds. Very similar to subsea cable, therefore very similar to terrestrial. So there's no inefficiency there. The third, if you can do those 2 things, then you achieve scale. Because what satellite can't reach, fiber can. What subsea can't get into, satellite can. So they mitigate their weaknesses and they build on their strengths. And one of the biggest strengths is lowest capex per gig delivered per mile, per subscriber, per pop than any other physical outside plant ever built. And that leads you to the last point, and that is for whatever the user is, a CSP, a CDN, a content delivery network provider, a streaming service provider, or even Meta and their dream of the metaverse, all comes down to business transformation. You can transform your business if you have scale, equivalency of service plant, and it's all converged on what would be a single platform.
Thank you very much, Bob Brumley of Laser Light Communications. It's been great talking to you. Thank you very much from Capacity TV.